I think I can start the session, right? All are ready. I have already provided the sheet on WhatsApp group, which we are going to use today. I hope you people have received it. Have you checked? Yes, please. It is downloaded by every one of you.
Yes, ma'am.
Okay. Thank you so much, Surbi ma'am. Fine. So I think we are starting with the today's session. Today is our day 3. We are at the mid of the FDP. Today I'm going to discuss the parametric tests, right? And also I'll discuss the t-test in the parametric test category, right? So as per the pedagogy, I'm starting with the theoretical concept, and then we will see how we can use Excel for performing the t-test, right? So I'm just sharing my screen. Okay, I think I shared my screen. Is it visible? Yes, friends, it is visible?
Yes, ma'am.
Yes. Okay, so yesterday we have talked about the non-parametric test, right? Today we will understand the concept of parametric test. So parametric tests are the tests which considers the normal distribution of data and based on population parameters. So these are the parametric tests. So if I can say, if I want to say parametric tests, I can say parametric tests are always considering the normal distribution of the data. Always in a statistics, there are certain assumptions for the tests, right? So in case of non-parametric test category, for each and every test has a very common assumption, which is based on the normal distribution, right? Means every test is requiring that data should be normally distributed if you want to perform a parametric test on it, right? So this is the one condition. Second condition is generally when we are inferring the population parameters, so we are using the parametric tests, right? Under this category, we can keep t-test, z-test, ANOVA, one-way, two-way, correlation, regression. All these can come under the parametric test category, right? Now, starting with the today's concept, that is t-test. So t-test, why we are using the t-test? First thing is that t-test is a parametric test, right? So it is what obvious. Generally, we are requiring the normally distributed data, right? Then question comes, what is the purpose or why we are using the t-test? So whenever we are finding the significant mean difference, so whenever we are interested to see whether the significance difference is existing in the two groups, generally we are using the t-test, right? So significant mean difference, wherever we are talking about the mean difference, we are talking about the t-test, right? So this is the purpose of using the t-test. Now, there is, I think those who are generally means those who have studied the theoretical background of the t-test, they generally know this thing. People are generally saying when the sample size is less than or equals to 30, right? Then we are using t-test, right? Sorry, not and it should be n. And the sample size should be less than or equals to 30. We are using the t-test. Vice versa to this, generally we are saying when the sample size is greater than 30, we are using the z-test. I think everyone will agree with this, yes or no?
Yes, ma'am.
Yes. So apart from this, means this is one condition, but it is not the only condition. One more condition is there. The next condition is what? Next condition is this, that the variance or standard deviation of population should be unknown. So the two major conditions which can help us to decide whether the t-test will be applied or applicable or not. So the condition is what? When the sample size is less than or equals to 30, and when the standard deviation or the variance of the population is unknown. In that case, we are using the t-test. And when the sample size is greater than 30 and the variance or the standard deviation of population is known, we are using z-test, right? So these are the two conditions which can help us to decide which test we need to apply. Now, when we are talking about the writing of the research papers, I think many of you have already observed whether the sample size is 30 or greater than 30, even that we are using the t-test. Because in statistics, there is a theorem named as central limit theorem. This theorem generally works on the concept that when you are increasing the sample size from 30 onwards, generally your sample is tending towards to the normality, right? So when the sample size is 30 or more, we can consider this thing that the distribution is normal of the population. So this way, on the basis of this, if we are having the sample size greater than 30 also, we are using the t-test, because we know this thing, means if I say writing of a research paper or conducting a research, generally we know this thing when we are talking about the sample, means it is like we are not having the complete knowledge about the population, or maybe we are knowing the population, but we are unable to collect the data of the population. So that way, if the data of the population is not available, we cannot calculate its variance or standard deviation, right? So it is but obvious when the standard deviation variance is unknown to me, I can use only the t-test. Because for the z-test, condition is this, you need to have the knowledge about the population variance or the standard deviation, right? So this is the very basic about the t-test. T-test is also known as the student's t-test, right? Now we are talking about the types. So when I say types of t-test, broadly we can classify the t-test into the two categories. That is one sample t-test and two samples t-test, right? When I say one sample t-test, in one sample t-test generally we will be having when I'm talking about one sample t-test, in case of one sample t-test, we will be having only one sample, that is variable, right? One sample, or just a minute, I can say, and one variable, right? So one sample meaning is that suppose I'm having the data of the weight. So one sample means suppose 15 people weight data available to me. So that way you can say I'm having only one sample data available to me and one variable data, that is weight of the 15 people available to me, right? So in this case, as I said, in case of the t-test, purpose is that you need to compare the mean, right? Means other way around, I can say I want to compare the mean, right? So when I'm having only a single sample, so the mean of that sample I will compare with which thing, right? So in that case, you need to compare mean. We will write compare the means of sample and population, right? So in case of one sample t-test, purpose is not that we are comparing the sample mean with the population mean, right? But I think I just discussed this thing. Generally, in case of t-test, population standard deviation variance is unknown. And why it is unknown? Because we are not having the clear idea about the population, right? So if I'm not having the idea about the population, how I can get the mean of the population, right? So that is why what we are doing in the one sample t-test, we are comparing the sample mean with the hypothesized mean. So whether you can use hypothesized mean or you can use known mean. Known mean meaning is what? That means you are having the idea about your population, so that way you can get the mean of the population. If you are not having the mean of the population, what you will do? You will assume that this will be approximate value of the population mean, and that way you can compare the sample mean and the population. Is it clear to everyone what I just said, or till now what I said? Yes.
Yes, ma'am.
Yes, ma'am.
Good. If it is clear, I'll go ahead and I'll talk about. Now, if it is clear, so that way we will further go and talk about the hypothesis. Right. So when I say hypothesis, we can make the null hypothesis like there is no significant difference in sample mean and population mean. Right? There is no significant difference in the sample mean and population mean. Vice versa to this, you can make your alternative hypothesis as there is a significant difference in sample mean and population. Right? Before moving ahead, talking about the two samples t-test, I need to talk one more thing here, that is one-tailed test and two-tailed test. I hope you people have heard this term.
Yes, ma'am.
Yes. So you need to understand this thing, what is one-tailed test, what is two-tailed test, right? Because this can help you to formulate your hypothesis. And using a one-tailed and two-tailed test, suppose if I am writing, maybe so I have written null hypothesis in the form of symbols. I have written mu is equal to x bar. That means I am saying mu is what? The population mean. X bar means it is a sample mean. So I am saying mu is equal to x bar. That is population mean is equal to sample mean, or there is no significant difference in sample mean and population mean, right? Alternatively, if I am writing mu is not equal to x bar, that means I am saying there is a difference, right? So if I'm writing there is a significant difference in the alternative hypothesis, that means I'm talking about the two-tailed test. Because here it is quite clear, I'm only saying there is a significant difference, but I'm not saying clearly whether the difference is greater than or less than, right? Other way around, if I am writing my alternative hypothesis like I can say it is one-tailed test, because here clearly I'm saying whether the population mean is greater than or less than to the sample mean, right? So when your population mean is greater than your writing, you are saying it is a right-tailed test. And when you are saying your population mean is less than, you are saying it is a left-tailed test. Right? It is clear, friends?
Ma'am, can you repeat this one? This one-tailed test.
Okay, I said H naught. Null hypothesis is mu is equals to X bar, right? That is, I am saying population mean and sample mean are equal, right? Alternatively, I am saying mu is not equals to X bar. That means population mean is not equals to X bar. That means I am not clearly mentioning the direction, whether the population mean is greater than or less than. That means here it can be either way. Maybe you can be less than also, it can be greater than also. That means both the tails are involved. That means the rejection reason of your null hypothesis will fall on both the tails of the bell-shaped curve. This is the meaning, right? But when I am clearly saying population mean is greater than, so the direction is clear. So it is a one-tailed test. And when you are saying population mean is greater than, it is a right-tailed test. When you are saying population mean is less than, so again, direction is very clear. That means you're talking about the left-tailed test, right? It is one-tailed test. Is it clear?
Yes, sir. Ma'am, if both the means are equal, what does that indicate? It means the characteristics of the sample are same as of the population, so it is a perfect thing.
Means sample is having the same characteristics whatever the population is having. That means sample is belonging to that population.
And if it is greater than the sample mean, that what does that indicate?
Means we are saying population is not representing that sample. Sorry, sample is not representing that population because the mean is similar.
And that is same in the case if it is less or greater. I mean, both are same.
Yes.
Okay.
So shall I proceed?
Yes, ma'am.
Yeah.
Yes, ma'am.
Now, I think no question, right? I can proceed, right?
Yes, ma'am.
Yeah.
Yeah.
Now talking about the two samples t-test, right? In case of two samples t-test, there are two categories. Independent samples t-test and second is dependent samples t-test. Right. First category where I'm talking about the independent samples t-test. So the name is clearly indicating you independent samples, means we will be having two samples which are independent because it comes under the two samples. So we will be having two independent samples, right? Again, as it is a t-test, so purpose will remain same. We need to compare the mean. So that way we will compare the mean of the two independent samples here, right? The purpose will remain same. You are comparing the mean, but comparing the mean of the two different samples, right? Those samples will be independent or unrelated to each other, right? So we can write here to compare means of two independent or unrelated samples. We are using the independent samples t-test, right? Now, next thing is variable requirement. What kind of variables are required here? I think in case of one sample t-test, I forgot to tell you. Here we will be having one variable and this variable will be your numeric or continuous variable, right? Coming to the independent samples t-test, here we need to have two variables. The first variable, that is one.
Numeric and which one, ma'am?
Sorry,
Numeric and which one?
you are talking about,
Previous one, yeah.
I think only numeric or continuous.
Continuous. Okay, okay.
Yeah. In case of independent samples t-test, we need to have two variables. Out of those two, one variable should be your dependent variable. You can say this should be numeric variable or continuous variable. Means this variable can be of the interval scale or ratio scale also you can write, right? Then we need to have one independent variable. IV means independent variable. And this variable should be categorical with two samples or groups. Right? Say for example, I want to compare the mean weight of male and female children or newly born male and female children, right? I want to compare their weights. So in that case, you can find we are having the weight variable, which is numeric or continuous, and we are having the gender variable. In this, we are having the two groups, male and female, and these two groups will be independent or unrelated, because we know this thing. If a particular child is a male, so he will be the part of only one group, that is a male group. He cannot be the part of female group. Likewise, if a child is a female, so he can only or she can only be the part of female group and cannot be the part of male. So that way, this kind of example you can maybe this example can help you to understand the concept of independent sample status, right? So this is one thing. I think assumptions I'm not talking about. As I already told you, one important assumption. Okay, I think I talk because I need to show you when we will go there. So I'm only talking about the two major assumptions of independent sample status. First one is the normality of DV, and second one is homogeneity of variance. These are the two assumptions, right, which we need to generally check before performing the independent sample status. If data is fulfilling these assumptions, that means you can go and perform the t-test, right? Is it clear? Independent sample t-test is clear to everyone?
Yes, ma'am.
Right. Moving ahead, talking about the second category, that is dependent sample t-test. So dependent sample t-test, again, name is itself telling us we need to have dependent samples, right? Before this, we need to compare means. Again, purpose will remain same. But in case of dependent sample t-test, comparison will be in the dependent groups, right? So here we are requiring one dependent variable, or maybe one numeric variable also you can call it. Right. So one dependent on one numeric variable we are only requiring in case of dependent samples t-test. But when you need to compare, so how you will compare when I am having only a single variable available? So with the single variable, I can get only a single mean, and I need to compare the means. So in that case, the condition says that means you need to measure EV twice. Within certain period of time interval, right? So this is, you need to understand. Suppose I'm saying I want to compare the performance of my students, right? Before teaching them how they were performing, and after teaching them how they are performing. So in that case, suppose I'm teaching, suppose introducing a new subject to these students. I want to understand what is their basic understanding about the subject. So maybe I can conduct one test before starting or before teaching them. That way I can get their scores, and after teaching again I can conduct the same test and I can collect their scores, and then I can compare whether is there an improvement in their knowledge level after teaching them or not. So that way you can understand this thing: performance before teaching, performance after teaching. So I'm having only a single variable, right? Performance variables. Twice I am measuring this variable using the marks and all, right? Second thing, I'm having the same sample. So here the condition is what you are requiring same sample. So we are measuring dV on same sample. So rather than requiring, I can say this thing, we are measuring dV or 1 dB on same sample twice, right? During a particular time gap. Is it clear? Friends, it is clear?
Yes, ma'am.
So that is why you can say the sample is, we are using, suppose I have taught to the 30 students, right? And same 30 students should present in the second conduct also. So that way there will be, or there is a possibility of dependency, because I am taking the score of one person twice, right? So how, or what is the knowledge level of his or her presently, and after that particular period of time, how he or she is showing or indicating us, indicating me the knowledge level of hers or his. So that way we can say this thing, that way dependency is possible only when we are using the same sample, right, for measuring the dependent variable. So this is a concept of dependent sample t-test. I hope the concepts of both the tests are clear, or means I can say all the three. One, independent and dependent. All three are clear to everyone? Any doubt so far? Yes.
Yes, ma'am.
Fine. Now I think how to formulate hypothesis and all we will see when we are performing all these things using the Excel, right? So I'm not talking right all these things, that how to write the hypothesis, right? So if the concept is clear of the t-test on all the three types of t-test, I request you to open the Excel sheet I have provided to you and then go to the demo sheet of the one sample t-test. Okay, I hope you people have opened it. Sheet is open.
Yes, ma'am.
Shall I
Yes,
proceed?
ma'am.
Yes. So you can see in the sheet I have provided you the data. The data is of height in inches mentioned in the column number A or maybe C. In my case it is C. Maybe I have added some inserted some new columns here. So that is why it is shifted to from A to C, right? Apart from that, I have mentioned one more thing, that is mu is 66. Mu is what? It is the population mean, right? Alpha is 5%, that is 0.05. This is the level of significance. So I want to compare the mean height of the sample and the population. So if you can recall, when I was discussing the concept of one sample t-test, I said to you, we need to compare the mean of the sample from the population mean, right? So if population mean is known to you, it is good. If it is not known to you, you need to take assumption. You need to see which variable you are talking about, in which context you are talking about, and that way you can take its average value as a population average value. You can assume that will be known as hypothesized mean value, right? And that way you can compare your sample mean with the population. In this particular problem, I have given you the mu value, which is 66. Suppose this is the data of the students who are studying in the college, right? So during the college life, I think generally we can understand this thing when we are talking about the India. In context to the India, what is the average height of the student, those who are going to college? That idea we can get usually, right? So that we can decide that this can be the population mean value. Is it clear to everyone?
Ma'am, if mu is not given, then we will calculate the mean of the sample.
I think I just said you need to listen very carefully. I said we need to compare the sample mean with the population mean. So sample mean anyhow we need to calculate. No argument on that. But you need to compare this mean with the population mean. So I said you need to, firstly, if you are having the knowledge about your population, you can get easily the population mean. But if you are not having the knowledge about your population completely, you need to assume this, because I have already mentioned in the Excel sheet where I have written here, you need to compare the sample mean with the hypothesized mean or hypothesized population mean or the known population mean. If which population is known, you will be having the mean easily available to you. If it is not available, you need to assume that what can be the population mean. So I have just given you the example. Suppose these are the heights of the students, those who are going to the college. So if this is the data of India, right? So in Indian context, if I'm talking about that, what is the average height of the students, those who are going to the college? So that assumption we can make. So that will be known as the population mean or the hypothesized mean. Is it clear?
Yes, ma'am.
Right. So as a procedure, if I want to compare these two values, firstly, I will write my hypothesis here. That is null hypothesis. I am writing there is no significant difference in the population and sample mean height of students. Is it clear? Is it clear, friends? Friends?
Yes, ma'am.
Yes, madam. It's clear.
Okay, so alternatively, I have replaced no with A. And I'm saying there is a significant difference in population and the sample mean height of students, right? Now, if hypothesis is formulated by us, now alpha value is already given to us, not given. According to our understanding, we can assume in which field we are working and what can be the appropriate level of significance that we can present, right? Now, I'll take you to the data tab or data menu, right? I'm suggesting you go to the data tab or menu and explore this data analysis toolbar. Click on this. Okay, so the box is appearing to you. You can see, as already I told you, all the tests are alphabetically listed here. So T is going little down. I'm coming down, and you can find we are getting the T test section here. It is showing you T test paired 2 sample for means, T test 2 sample assuming equal variances, T test 2 sample assuming unequal variance. Nowhere 1 sample T test is mentioned. So we can understand this thing using the data analysis toolpack. We cannot apply the t-test, right? 1 sample t-test. So what you need to do, again, you need to do little bit manual work here. And then using the function, you can get the p-value. And that way you can decide whether you are accepting or rejecting the null hypothesis. So for the purpose, I have already given you the formula which can guide you that how you can get that p-value, because for getting the p-value, if you will see, I have given you the functions here. In case of 2-tailed p-value and 1-tailed p-value, you can find in both the cases, if these functions are asking us to provide the calculated value of the t. So we need to calculate the t value first, right? Till here, I think I'm clear. May I proceed?
Ma'am, from
Yes,
where you
madam.
found the tab of data test?
Sorry?
Data test you were discussing. No, ma'am, these tests are available in data analysis.
I think we have used yesterday also
Yes,
data analysis toolpack.
but now it is not visible, ma'am, in the data tab.
So you can do one thing, you can close this and open once again. Sometime it happens, I told you, sometime it happens. So you need to maybe restart your system.
Okay.
That way it will be visible to you, or you can follow the procedure of adding it again. Go to the file, options, add-ins, go, and then check that box and click on OK. So maybe it is visible to you. Sometime it happens.
Okay, ma'am.
Right. Now, Okay, so I can come here and you can see, if I talk about this particular formula, so what are the things which are requiring us to get the t value? First one is the x bar, that is the sample mean. Second one is the mu, which is the population mean. And in the denominator, you can find it is sx bar, meaning is what? It is the standard error of mean. So standard error of mean, you can see the formula I have given to you. It is the standard deviation divided by the square root of the n. N is what? It is the sample size, right? So that means we are requiring x bar, mu, standard deviation, and the value of n. And that way we can get the t value, right? So what I'm doing, I have written here mu. I need to have the mu, that is the population mean value. Then I need to calculate the sample mean. Then I hope till here I'm clear. May I proceed?
Yes.
Then for getting the denominator, I need to have standard deviation. I need to have the value of n. Right? Using this, I will calculate standard error of mean. And then I'll calculate the t value. Okay, fine. Fine. Everyone note it down. Those who are performing.
Ma'am, this 66, now the upper one, this this is population mean, u,
Yes.
and the nu which we are finding is sample mean.
No. I think rather than inserting this symbol, I have written mu because we can read it as mu, mu. So I have written it as, it is like this. There's no difference in that. The meaning value will be 66 only.
Acha.
Right? So I have entered using my keyboard. I have typed here in the next cell. I have typed here 66. Right? Now for getting the mean, we will use the function called average. And I need to select the range of my data.
Sorry.
Right? Then I can close the bracket. I think average we all know how to calculate. We have already done this. So you can do, or you can supply the range, which is C3 colon C14, and then press enter. So this is the average height of the sample, right? If you wish, you can write in brackets, it is for sample, right? Maybe more precise. Done.
Yes.
Then we will calculate the standard deviation. We already know STDEV is the function which we are using to calculate the standard deviation, right?
Yes, ma'am. It's 1.64.
So you can give the range. I think the range was C3 to C14, right? Yeah. And then press enter. It is 1.64294. Fine, everyone. No problem till here. May I
No,
proceed?
ma'am.
Yeah.
Yes, ma'am.
Now, n is the sample size, right? So if sample size is large, you can use the function called count and then give the range. It will give you the sample. Right? Shall I proceed?
Yes, ma'am.
Yes, ma'am.
Now, standard error of mean. So I think I already shown you, and then in your Excel sheet also the formula is written. It is standard deviation, which is we have already calculated. So I selected this cell. Divided by, I need to type SQRT. I will use this function and I will provide the cell reference of the count, which is N12. Clear? May I enter?
Yes, ma'am.
Yes, madam.
Yes. So this is the standard deviation value. Sorry, standard error of mean value. Fine. Now, I will get the denominator first. Not denominator, numerator. Firstly, I am calculating the numerator of my formula, which is x bar minus mu, right? Putting equal, x bar is this minus mu is this. Then
Yes, ma'am.
Enter. Yeah. Now we will get the T statistic or T state value or the T calculated value, which is numerator divided by standard error of mean. Done?
Done, ma'am.
So this is the T calculated value. Now we need to calculate the P value. Done? Shall I proceed?
Yes, ma'am.
So I'm using T dot dist dot 2T. Right? This is asking me to provide the X. X is your calculated T value or T state. T state is your calculated value. Comma. This minus 1. Or maybe directly you can also type 11 because it is asking you for providing the degrees of freedom. So degrees of freedom will be n minus 1, which is 11. Maybe you can select and type -1 or you can directly enter 11 also. Both ways will work. Right? Fine, everyone. May I enter?
Yes, ma'am.
So I hope everyone is getting the same figure, 0.00046. Yes.
Ma'am,
Yes. 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 Are you getting?
ma'am, how did you get this mean and SD? I was not present. Can you please repeat?
Which one?
First one, MU के नीचे mean of the sample and SD.
Average function you need to use. Already I told average you need to calculate and standard deviation you need to calculate of the sample. And already in the descriptive statistics we have understood how to get the average or mean value and the standard deviation value. Got it?
Yes, ma'am.
No, okay, thank you, sir. But what about the ma'am? I think it was Ketki ma'am. Have you got it?
No, ma'am, actually I was not present, so I'm just copying
But
whatever
I think you can see, no, I have written here equals to average and the range I have provided. So I don't think so it is tough to understand. Not getting still?
Ma'am, 1 minute. Divided by 12, ma'am.
I think you go step by step, ma'am. Don't go jump directly on the end. Firstly, calculate the average. Calculate it.
Average may equals to average, then
Range of the data.
range of the data.
And then
68.33
similarly, standard deviation function is STDEV.
equals to STV.
Once you are typing ST, you can see it will
ST.
will be there in a prompt. STDEV.
Ma'am, only DEV, कुछ P नहीं उसमें.
Population standard deviation we are not calculating, no? We are calculating the sample standard deviation.
Okay. So here also the same range I have to copy.
Obviously, for the sample we are calculating.
Yes, ma'am.
And it's a count.
Yes. Yes. And SE will be
Standard error of mean. Already in the sheet, I think I have given you this. Standard
Yes.
error of mean SD divided by square root of the n.
so SD divided by means I can take this divided by STQRT. Ma'am, ये कैसे आया?
You need to type. This is a function.
अच्छा.
You need to type.
Okay. And then N is 12.
You can type also. Not
Ah.
necessary you need to select. You can type also.
So it will come to 0.474. And the
Then,
numerator,
then this formula you need to apply. So to make things easy, I have calculated numerator first. The difference of both the means. population is standard, sorry, sample mean minus population mean.
Sample mean.
You need to see the formula, ma'am. I think I will suggest every one of you do not depend on my calculation. Only see what formula is asking you. It is asking you in the numerator. It is asking the difference of your means. So that way, numerator I calculated as the difference of the means. Done.
Just a minute, ma'am. Just a minute. Ho raha hai. Ek minute. 2.33.
And then
T stamp.
T is statistic value or T calculated value. That is numerator divided by denominator. Denominator is the standard error of the mean. So I selected these two. The division of the numerator and the standard error of mean will give you the T value.
Division of numerator.
Again, I say please look at the formula. Because mugging up is very easy for every one of us, right? So rather than mugging up, you try to understand the concept I suggest.
Yes, ma'am. Today only it's happening because
No problem, no problem. I'm waiting up because I think I'm giving you time. Don't worry. But it is like I'm giving a general statement for every one of you. I'll just say, you can only see this is a way I have calculated the thing, but it is not necessary you need to follow me, because if I want to get the T value and the formula is already written, so I think we are knowing how to get it in a single. Suppose if I am talking about this, right? So in the single formula or in the single cell also I can calculate this, but it will be very tedious for every one of you. So that is why I have done it step by step, right?
yes, ma'am. And then last one, p value. It is, ma'am, one-tailed we are taking. So dot RT.
RT. Yes. I'm showing you how you can calculate in a single go. Right? You can see we got the value of T in a single cell also. So this is also you can follow. But I think it will be very difficult to understand. So that is why I have shown you step by step.
And ma'am, what is the formula for the p value, ma'am? One-tailed or two-tailed?
Already it is two-tailed we are using.
Sorry.
I am using two-tailed.
Okay, okay. I took the one-tailed only.
No issues. You can multiply that by the 2. It will give you the two-tailed p value.
Calculated T matlab 4.92, comma 11. 12 minus 1.
11.
Yes, ma'am, got it.
Okay, so I think everyone has got this. If this is your p value, you can compare it with the level of significance and you can say it is less than 0.05.
No.
If it is less than 0.05, that means what we will do?
Reject.
We will reject the null hypothesis.
Null hypothesis.
That way, if I am rejecting the null hypothesis, I will conclude there is a significant difference in the population and the sample mean height of the students. Right? Means mean height is differing when I'm comparing the sample and the population mean. Right? If I need to conclude this result in a one-tailed form. So then I can compare sample mean and population mean. As the difference is coming, so I can compare now. I can say sample mean is, population mean is less than sample mean. Right? Sample mean is 68.33, population mean is only 66. So that way I can say the sample mean is greater than population. Is it clear?
Yes, ma'am.
Okay, to everyone it is clear? Shall I proceed to the next?
Ma'am, I tried to calculate it through the single formula, but there is some error. I think bracket or something is missing.
Possible for you to share the screen?
Just a second, ma'am.
Means it is possible. Can you share?
Yes, ma'am. Yes, ma'am. I'm sorry.
Sorry, sharing. Are you sharing the screen? Do I need to stop share my screen?
Yes, ma'am. Can I share it so
Yes,
you
yes,
can?
you can share. I'm
Yeah.
stop sharing my screen. You please share. You can share, sir. I have stopped share my
Is it
screen.
visible, ma'am?
Yeah, I think it is started. Just a minute.
Okay. Just a second. Let me just.
Yeah.
Okay. Now in this formula, I think something is missing.
One extra bracket you have given at the end, maybe.
Just a second. Let me. No, still there is some.
Again, click on this. Just a minute. Average C3 to C14 minus 66. Okay. Bracket close. Numerator done. Standard deviation of C3 colon C14.
I think one more bracket is
You need to close the bracket of after C14, B14.
B14. Okay, just a second.
Yeah.
Okay.
Just a
It looks like I'm missing.
Just a minute, sir.
Yeah, ma'am.
Yeah. Now, after at the end, you have put extra bracket. You need to remove bracket, sir.
Okay, okay. Just a second.
Now enter.
Yeah, okay. Now it is. Yeah, thank you. I'm stopping my.
Yeah.
Thank you.
Thank you, sir. So, shall I present my screen now, right?
Yes, ma'am.
Yeah. Okay, my screen is visible.
Yes, ma'am.
Yes.
Fine. So I think one sample t-test is clear. There is no doubt in one sample t-test. Next sheet is for the practice purpose. You can use this data to perform one sample t-test if you wish, right? If you want to do a practice. Now I'll move to the next sheet named as two sample, demo t-test. No, sorry, demo. What is the name this time? Demo independent. Then I need to delete my older calculations. Done, everyone?
Yes.
Fine. Now you need to see here we are having the data of the students, male and female students data. Study hours data is given to us, that how many hours in a particular week, how many hours are studied by the female students and male students. So this data is given to us. First of all, I need to see, suppose the purpose is that I want to compare the means, whether the female have studied more or the male studied more. I need to see this thing, right? I need to compare the mean study hours of the male and female. So in that case, firstly, I need to see as comparison of the means is there. So that means I can go for the t-test. But I need to see how many variables are given here. So I think study hour is given to us, right? Which is our numeric variable. Yes.
Yes.
And second variable is the
Gender.
gender. Very good. This is the categorical variable. And there are two labels, male and female. Done. So that means purpose is served. If I want to perform, I want to compare the mean study hours of the male and female students. I can say I am having the data available according to the independent samples t-test, because two groups, male and female, are independent or unrelated with. It is quite obvious if a particular student is female, she cannot be the part of male group. Likewise, for the male also, you can say this. So that way these two groups are independent or unrelated to each other, right? So if I want to compare the means, I can go for the independent samples t-test. So the purpose is served here and the data is available to us, which is required for the independent samples t-test. Till here it is clear to everyone? Now, we will formulate the null hypothesis firstly. So we will write there is no significant difference in the mean study hours, male and female, right? Vice versa to this, alternatively, I can say there is a significant difference. Then
Yes, ma'am.
Like, are you presenting?
sorry, anyone?
Yes, ma'am.
Okay.
The screen.
I hope it is fine. May I proceed? May I proceed, friend?
Yes, ma'am.
Yes.
Fine. So hypothesis is done. Suppose I want to test this hypothesis at 5%, right? Now, moving ahead, as I told you the assumptions. Suppose I'm considering this thing, data is normally distributed, but I need to see this thing whether the equality of variance is there or not. Why so? Because once you will go in the data tab, you will go in the data analysis toolbar. Click on this, right? Go down. You can find we are having the two sample t-test available, and there are two categories. First one is t-test, two sample assuming equal variances. Second one is t-test, two sample assuming unequal variances, right?
Yes.
So now we are not having the idea whether the variance is equal of the study hours or not. So this idea we are not having. So suggestive is this: if you are not having that idea, you can go for the unequal variance, right? Right? But if you wish to check whether the variance of study hours is same in the male group and female group both, so you need to see how you can do that. So you need to tell me which way I need to go. Directly I'll go for the unequal variances, or I need to firstly confirm whether the variance is equal or not.
And confirm whether they are equal.
Confirm. Okay. So if we need to confirm this, so I'll suggest you go little up under the F section. You can find in this section you can find the test which is named as F test, two sample for variances.
Yes.
So I suggest you select this one, F test, two sample for variances. Click on OK now. I hope everyone has located this. May I click on OK?
Yes, ma'am.
Right. Now once you're clicking on OK, you can see the dialog box is appearing, which is asking you to provide the input data, input range of the variable 1 and variable 2, right? So under the first box, in this box, I'm providing the range of the female group. So the range is A2:A8, right? Coming in the second box, selecting the second range, which is B2:B7. Then same ranges, I think you people have also selected A2:A8, B2:B7. Okay. Now labels, this checkbox I am selecting because I selected my data including the labels or the headings of the columns.
Acha. Ma'am, when we are selecting the variable, we have to select the label also.
Obviously.
Variable range.
Otherwise, yes, statistical test cannot be performed on the categorical data or the qualitative data. So you need to specify that you have selected the first row in which there is a labels. So that way, Excel will exclude these and will consider the data from here.
Excuse me, ma'am. When you selected female, you selected all the females till, like, the number is given 52. Till 52 we have selected. And then in variable 2, we are selecting this male, right? Okay, thank you.
I think I told the range is A2 to A2:8 and B2:B7.
So I have to take female word also in my range.
Not necessary. If you are selecting the male female means labels, so you need to check this box. If you're only selecting the observations, in that case you do not need to check this box.
Isa nahi, ma'am.
So, ma'am, that means you have selected the this heading as well, female and male, right?
I think I already said, that is why I'm repeating twice. I repeated what is my range, and same sheet I provided to you people. So I think same will be the range in your case also. So I said range is A2 colon A8, B2 colon B7. That means it is clearly, you can see also. A2 means this is
Okay.
column A, 2 means this. So A2 is female, B2 is male,
Okay, ma'am, done.
right?
Understood, ma'am. Thank you.
Alpha is by default 5%. That means if you wish to change, you can come in a box using your keyboard, you can change it. But I think I'm not changing. I want to check this or test this hypothesis at 5% only. Going down in the output options, I will go with the first one. I will generate my output in the same sheet. But up to you people, in whatever way you want to get your output, that you can select. I think this is all you need to do. Now we need to click on OK. So I hope I can click on OK to get the output. Everyone, it is fine. May I click on OK?
Yes,
Yes,
ma'am.
Yeah. So the output is generated by Excel for us. You can check here. This is telling you F test two sample for variances. In that you can get. Initially, we are getting the descriptive statistics, which is showing you the mean, variance, and the number of observations. You can check the mean study hours of the female at 33, for the male 24.8. Variance 160 for the female, 21.7 for the female male. Observations 6 observations in case of female, 5 observations in case of male. These are the degrees of freedom. Now F value we are getting as 7.37. Right?
Ma'am,
Yes.
sorry, ma'am. Ma'am, when I click that OK button, now it is showing having trouble to offset input-output reference. When I
You
selected
have made some
range.
problem means in the same sheet you are generating the output.
Yes, ma'am.
So once you have clicked on that first option, so you need to come in an opposite box. Maybe you have not came. In that case, your range of the input has changed. So close this, again apply.
Okay, ma'am. Okay, I will do that.
So shall I proceed for the interpretation or do I need to wait?
No, ma'am, you can proceed, ma'am.
Okay. But this is important for you to understand because you need to do some calculations here. So that is why I'm telling you, you can perform afterwards. First understand this thing, right? So this is the F value which we are getting. And then as the notion, we know this thing that we need to generally use the P value for making the conclusion. So the P value which is came here is P value 1 tail. We are not getting the 2 tail value. Generally, I suggest we generally go for the 2 tail P value, right? So if it is not coming, what you need to do, you can convert this value in the 2 tail value. How? I'm writing P.
Multiply by 2.
Yes.
Multiplied by 2.
Very correct. So P2 tail I'm calculating here, which is I'm selecting this, multiplying this by 2. Done. So the value I am getting, I need to compare this with the level of significance, which is telling us it is greater than 0.05. It is 0.07, which is greater than 0.05. That means I need to hold or accept the null hypothesis. But I think you need to understand this is for the F test. So you need to understand what is the null hypothesis of the F test. I have not told you that right now. So in case of F test, the null hypothesis will be, you can write here, variance is equal. So please be careful. This is the P value for the F test. So we need to only have the null hypothesis of the F test. So hypothesis is variance is equal. And we are accepting the null hypothesis. That means we are saying variance is equal. Means the study as variance is equal in male group and female group both. This is the meaning. Clear?
Ma'am, null hypothesis, so we have already created now that there
For the
is.
t-test, that is for the t-test. That is why I'm telling everyone of you, please listen carefully. This is for the F test, not for the t-test. We have just applied F test right now,
Okay, ma'am.
right? So
Got
for
it.
F test, the null hypothesis will be in terms of variance.
Okay. Yes, ma'am.
So conclusion is this: we are saying variance is equal. So now it is clear. We will go for the equal variance t-test. Clear?
Yes. Yes, ma'am. Got it.
Now go again to the data analysis toolpath. Going down, selecting t-test, two sample equal, assuming equal variances. Select this one and click on OK. I hope I can click on OK. Everyone has located this. Friends say yes or no. Nobody is saying anything. Shall I proceed?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Yes, yes, yes. Fine. So I selected the option, and I think I'm getting this dialog box. Everyone is getting the same, right? Now, in this dialog box also, you need to provide the range of your both the variables, right, or both the groups. So in the first box, I'm giving the range of my first group. In the second box, I'm providing the range of my second group, right? So again, range will be A2 colon A8 and B2 colon B7. Everyone is getting the same, I hope, right? Selected the same ranges. Done?
Yes, yes.
Now, yeah. Now in the next section, it is asking you hypothesize the mean difference. So we are not assuming what is the difference in the mean of both the groups. So that way I am leaving this box empty. Do not supply anything in this dialog box. In this particular box, right? Next, I'm selecting the checkbox labels as I selected the data, including the headings of my columns. So I selected this checkbox. Alpha by default is 5%. I'll go with this. Output range, I'll come here and I need to select which will be the output range for me. So I'm selecting a blank cell from my same sheet, right? And then I think I can press OK. Tell me, may I go for OK? Shall I go?
Yes, yes. Please go.
Okay. So I hope everyone is getting the same output like mine. I will now explain you. Yes, thank you everyone. Now I'm explaining you the meaning. Now you can see at the initial level, whatever we are getting in the F test, same we are getting here. Because it is very obvious we are providing the same data here, right? So the descriptive statistics will not change. Mean study hours, variance in the study hours for male and female is listed in the first two rows. Number of observations in the male group and the female group is listed in the third group. Next comes the pooled variance, right? So when we are going for the equal variances, it will give you the pooled variances value. Means it is combining both the groups, male group and female group, and then it is pooling them and giving the variance value. Now it is coming as 98.533. Hypothesized mean we haven't passed anything. So that is why we are getting the 0 here. Degrees of freedom will be plus means 6 plus 5, 11 minus 2, which is 9. T calculated value or T statistic value is 1.36. In the next section, you can check we are getting the P one tail value, T critical value for the one tail, T two tail value, and the T critical value for the two tail. So we need to only focus on these two, right? Now, if I want to make my decision on the basis of P value, I can compare this with the 5% and I can say it is greater than 0.05. Yes?
Yes.
So if it is greater than, that means what I'll say?
Accept HO.
I'll accept the null hypothesis. So this time I'm accepting the null hypothesis of the t-test, right? So I can say this thing, there is no significant difference in the mean study hours of male and female students, right? Although once you will look at the mean value, you can find there is a huge difference. Female students study hours are 33. This is the mean value. For male, it is 24.8. But statistically, it is coming as there is no significant difference. Might be possible we are having the unequal observations also. Maybe we can increase one more male data. Maybe it can increase its mean, maybe, right? So that way we can say this thing, that our results are saying that there is no significant difference in the mean study hours of male and female students. Is it clear?
Yes, ma'am.
Okay. What about others? Clear to everyone?
Yes, ma'am.
Yes, it is.
Fine. If it is clear, yeah. Thank you everyone for the confirmation. Next sheet is the practice sheet. You can check it and you can perform the practice sheet or use the practice sheet to perform the independent sample t-test on that, or maybe you can use the same sheet again, right? And you can do the calculations. So that way twice you can perform independent sample t-test. Now moving to the next sheet named as paired. I hope everyone has got it.
Yes. Yes, ma'am.
Okay, so firstly I will understand what is given to us here. In this sheet we are getting the weight in pounds before and after. Meaning is that suppose there is a company which is saying to the people that they are offering a diet plan. If people will opt that diet plan will help to reduce the weights, right? So the people, those who want to reduce the weight, they can opt for that particular diet plan. So suppose there are total, how many? 8. So there are 8 people who wants to reduce their weights, right? So they have opted this diet plan. So company has noted down their weights. So these are the weights before opting the diet plan. After opting the diet plan, whatever the time period has company is suggesting that you need to take this particular diet plan for these number of days or something. So after that, again, company is noticing or measuring the weight of the people. So these are the after diet plan weights, right? Now we need to see, or now company wants to see whether the diet plan has impacted the weight or not. Means there is any reduction in the weight after opting the diet plan or not. So that way you can means company is interested to see the mean difference is coming there or not, right? So if I want to perform paired sample t-test, you can see in both the cases, we are assuming that the company is taking the same 8 people weight before opting it and after opting the diet plan. So same 8 people data is available, right? And we are having only a single variable, which is weight. So weight has been measured twice by the company, before and after condition. So this way, this is the condition which is perfectly suiting to the paired sample t-test requirement, right? Now you need to make your null hypothesis, right? So I think I'm deleting and writing again for every one of you. I'm writing the null hypothesis will be there is no significant difference in the mean weight before and after the diet plan, or before opting and after opting the diet plan. Up to you, whatever is more easier you to write or to understand, that way you can write. Alternatively, you can say there is a significant difference in mean weight before and after opting the diet plan. Fine.
Yes, ma'am.
So null and alternative hypothesis, I think we have written. Now we have already checked the whatever is the requirement is fulfilling the requirement of the paired sample t-test. That means we can perform it. So we need to go to the data menu or data tab. Click on the data analysis toolpath. Going to the downwards, you can find t-test paired to sample for means. So the dependent sample t-test, other name is also paired samples t-test, right? So I'll select this one, first one. I hope everyone has located the first one.
Yes.
Right. Click on the OK then.
And what's a pair test?
Paired. Pairing is there. For the same people, you are taking data twice. So there is a pairing in the weights. Right?
Acha, t-test paired to sample for means.
Hmm.
T-test paired to sample for means. Okay.
Now once you're selecting it, you are getting this dialog box. We are
Yes, ma'am.
providing the ranges of both the conduct of both the samples. So I have selected variable 1 range as A3 colon A11, and in the
Yes.
next I am selecting that is B3 colon B11. This is
B11.
my range, right?
Yes, ma'am.
Again, hypothesized mean difference I am not providing. I am not saying what is the mean difference in these two different samples or in the two dependent samples. So I'm not notifying anything here. I'm making it or keeping it blank. Labels I'm selecting as I selected the data, including the labels. Alpha by default is 5%. We'll go with this. Coming to the output option, I'll select the first one. Up to you, wherever you want to get. I'll select this one and click on OK. So I hope I can click on OK.
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. Fine. So the output is generated by the Excel for us. You can check it. Now I'll go and I'll explain you the interpretation of it. So you can see mean weight before opting the diet plan was 169.625. After opting the diet plan, it is 150.25. Variance in the weight before opting the diet plan is 65.125. Variance in the weight after opting the diet plan is 121.929. Observations are 8 and 8 in both the groups. Pearson's correlation will always come when you are talking about the paired samples t-test, as there is a pairing in the samples. So always you are getting the correlation value. It is indicating there is a weak correlation in the two different groups, right? Before and after. But it is negative. That means somewhere there is an impact of the weight. Somewhere there is an impact of the diet plan. Hypothesis mean difference, we have not passed anything. That is why it is coming 0. Degrees of freedom will be n-1, which is 7. T statistic value or T calculated value is 3.70687. I'll select these two as I will interpret my results using this. So P value for the two-tailed t-test, if I talk about, you can find it is 0.0759. Just less than 0.05. Yes. That means we need to
It's less.
we will reject. Yes. So when I'm rejecting the null hypothesis, what I will say? I'll say this. So I will conclude my output results on the basis of alternative hypothesis. I will say there is a significant difference in the mean weight before and after opting the diet plan. So when the difference is coming, I can compare the before diet plan mean weight was 169. After opting it, it is 150.25. That means I can say this thing. There is a reduction in the weight after opting the diet plan. Yes or no?
Yes.
Clearly it is visible. When difference is coming, I can comment this. So I can say this thing that the diet plan is effective. Right?
Yeah.
Right.
Yes,
So
ma'am.
this way, this is the paired samples t-test. Now for practice purpose, I have provided you one more sheet. You can use this and you can practice the paired sample t-test at your end also, right? So now I will go for the conclusion of the session and then I'll take your questions if you are having any, right? So friends, today we discussed the concept of parametric test. Parametric tests are the tests which are generally considering the normal distribution of the data. This is the main assumption of the paired parametric test, right? And generally when we are dealing with the numeric data, we are talking about the paired samples, right? When we are inferring the population parameter using the sample statistics, we are talking about the parametric test, right? In this category, there are, or in this particular family, there are so many tests, like T, Z, ANOVA, portion, regression, n number of tests are available in this category. Today, we started with the t-test. So I told you, the purpose of t-test is what? We want to compare the mean. Whenever we want to see whether there is significant difference in the mean or not, we are using the t-test, right? So in the t-test, there are categories like one sample and two samples. In case of one sample t-test, we will compare the sample mean with the population mean. Population mean can be the known mean or it can be the hypothesized mean. Known mean is when you are knowing your population well. In that case, you can get the mean of the population. But when you are not knowing the mean of your population, you need to hypothesize, you need to assume its mean. And that way you can compare it and you can reach to the decision. Second is the two sample status. That means where you are having the two samples, you're talking about the two sample status. In this category, firstly, we have talked about the independent sample status. There I explained you, again, purpose will remain same. We will compare the mean. But here we will compare the means of the two groups, two unrelated groups, because this is independent. So the groups should be independent of each other. So the variable requirement will be, we need to have two variables here. First will be the dependent variable. This can be the numeric or the continuous variable, and second will be the categorical variable with the two groups or two samples, right? And then you can formulate your hypothesis, you can perform the t-test, and you can reach to the conclusion. But to reaching or for deciding upon which independent sample t-test you need to apply in Excel, there are two varieties: equal variances, unequal variances. So I think I told you how you can check the variance is equal or not using the F-test. F-test for the variance testing is available in the Excel. Using that, you can decide whether the variance is equal or not, and that way which t-test you need to apply, that you can select. And then it is, I think, very easier. You can get it all the output, and using the p-value you can make your decision. Lastly, I explained you the paired sample t-test, which is the dependent sample t-test. So here we will be having the dependency in the sample. That means we are using the same sample, and for the same sample you are collecting the data twice. So that way this dependency can be maintained here. And here we will be having only the single numeric variable, and that variable you are measuring twice. So just we have understood the concept. We are having the 8 people data, so sample is same, 8 people data. So same 8 people weight we are measuring twice, right? So the variable, single variable is the weight variable. So that way you can understand this concept, that in which condition you can apply paired sample t-test, and then using Excel, selecting your data, you can get the output. Looking at the p-value, you can decide upon whether the data is supporting the null hypothesis or not, and then you can reach to the conclusion, right? So this was the summary of today's session. Now I think I'm asking you, the platform is open for the questions. If you are having any questions, you can ask, and if I can answer, that I'll do.
Hello.
Yeah.
Madam, in this sheet you have said that in Pearson correlation, if it is negative, then it is correlated with that plan. So at the same time, if two-tail p-value is less than 0.5 and it is and Pearson correlation value is positive, then what could be the
Positive correlation
meaning?
indicating that the direction of the change is same. If one variable
Okay.
is increasing, other variable is decreasing. Negative meaning is one variable is increasing, other is decreasing. That means here negative meaning is that after there is a reduction in the weight. So that is why it is coming negative.
Okay. Thank you, madam.
Yeah.
Madam, as you rightly said, that first we need to check whether the data is having normal distribution, then only we can apply t-test.
Yeah, this is the
That is the basic rule.
Yeah. So you can perform descriptive statistics firstly, and then you can decide. Yeah. Anything else? Amber sir has raised the hand. Sir, have you asked the question? Okay. Any other question, friends?
Ma'am, just one request, not any question.
Hmm.
Ma'am, the practice sheet which you have given, we practice over there, and tomorrow can we discuss if there is any issue with that practice sheet?
Yeah, I do not have any problem. Up to you people. If you are having any query, I will, and if I can resolve, I'll do.
Yeah, maybe at the starting of the session for 5 minutes only,
Right.
if everybody is okay.
Yes, everyone is okay, I think so.
Thank you,
For
ma'am.
that, ma'am.
Even I do not have any problem. I think I join at 5:30. Meanwhile, people are joining. If you join, and if you are having any query, you can ask me.
Yes, ma'am. Last night, what yesterday we did, na, I practiced that. So one thing I got correct, but second variable I was having some issue. So today I didn't have the time. So वरना मैं आपको आज पूछती.
Okay, fine. Okay, so Amber sir, you can write in a chat if you are unable to unmute yourself. There is some problem at your end. You can write in a chat. I can read there. Okay, you have no problem. Okay, no issues. Okay, any other query?
No, ma'am. Thank you. From
Okay.
my side. Thank you.
Okay. Thank you, everyone. This
Thank
is
you.
all from my
Thank you,
side for
ma'am.
the day. Okay, thank you, Pallavi ma'am. If no queries, I think we can end the meeting today. We are meeting tomorrow for the next category of the test, which is ANOVA, right?
Yes, ma'am. Thank you.
Okay, ma'am. Okay, thank you, ma'am.
Thank you. So thank you, everyone. Good night. Meeting tomorrow for the next second last session. Okay, over to you.
Thank you, madam.
Thank you.